Evening all. Are we all good? I do hope so. Kittens are fine, thank you. They're in the main house now, so they're running around, ripping everything up, doing what kittens do. Likewise, Festus. Good to see you too. Yeah, I've kind of tried to transition more towards standing rather than sitting. Like I got a standing desk, well, about a year and a half ago, and I rarely stand at it, and I figured it was about time that I actually do start standing at it. Thanks. Yeah, it's kind of a joke with me here. I say that quite a lot. In fact, I've even got, hang on, I have a sticker on my PC. It's childish, but it's funny. It's a well-known fact that I have the mental age of a 12-year-old. Yeah, it's funny enough, we were talking about that today. It's like, at what point do I take down the decorations? Like, all of the house is still decorated, and we can't quite bring ourselves to bring it down. It just looks so good. We just, like, leave the decorations up for as long as we can just physically get away with it. There's nothing wrong with being the last person in the street to take your decorations down. So, what are we doing? What day is it? Sunday. That means Caravella, doesn't it? So, here is a Caravella I prepared earlier. Why are we so far away? So on our last stream, which was before Christmas now, I think, we were doing the Sublight flight and the RCS thrusters. So we will continue with that and kind of work out where we got to. Yeah, we were working on the collisions and making sure that one ship can collide with another, and that we can fly it around properly. I guess part of that is also having other stuff in the world to fly around. Because there's no point in having sublight engines if you've got nothing close enough and small enough to be able to kind of navigate the ship around it. I want to get to the point where we can hug the donkey in Orbital parlance. So that's basically kind of strafing around something. Just going to hit begin play a minute. Oh, not in multiplayer because that's going to crash stuff. Oh, yeah. Forgot it started down there. Ah yes, I remember now. We had many potatoes. If you've ever watched the Orville, there's a maneuver they call hugging the donkey, which is where you just kind of just strafe around your target, keeping the nose pointing at it the whole time. I can't remember whether that was a second ship or the proxy for this ship. Oh, Shuttle's going places too. Right, so if memory serves, the controls we had set up are actually for, yeah, they were for that one out there. It's difficult to navigate around potatoes. No, that one. Okay, so we need to transfer these controls to this ship so that we're not controlling our little proxy dude out the window there. So I need to remind myself where I got to with all of this. Right, so that one... Yeah, so that's actually a flyable ship, which we are controlling via the broadcasts. So we need to remove the Caravella one, because basically we need to convert that into a proper flyable warpable ship. So I guess we need to take a bunch of the stuff we've got from here. So we don't need all these old inputs because they're now being replaced. But what we do need, yeah, some of our looping functions to tell the game where the ship is, and we need some of the warp stuff as well. And then the autopilot's going to have to work differently too. So the autopilot's going to be a fun one, because before we were just pointing the ship at our target, but now what we need to do is actually physically fire the thrusters to point the ship at the target. So we need to know like which thrusters to fire, and then we need to work out, you know, how quick the nose is turning, and then at what point do we fire the opposing thrusters in the right time to bring the ship to a stop on that target. It's going to be challenging. Oh, did I not surf myself to a way? No, I didn't. Ignore the ping, that was me. Oh, and Claire has just reminded me, so it's a good job it pinged actually, she's reminded me that it's the competition. I had completely forgotten. So we're going to need one of them. And we're going to need one of them. So yes, as Claire has quite rightly pointed out, it is competition day. So same as always, we've got 2 captains to give away. Thank you very much, Max. That was very generous. And 3 keys for dev builds. So we shall go ahead and do that. Claire, can you please let us know when you're ready? Righty-ho. Okay, so our first captain rank goes to 1015. And that is Avlin the Sparky. Congratulations. You are now a captain. Just wait for Claire to say she's ready to continue. Okay, next captain rank goes to 8154. And that is Nostromo's cat. Which is very cool because our cat is called Jonesy for a reason. Congratulations. Okay, and now on to the keys. First key goes to 927. All the best for everyone. Great name. Oh, actually 2 winners, and also well today. Congratulations both. Is it? Next one goes to 3806. That is Lodestar. Congratulations. You have a key. I don't know actually, CSI. I just let Claire sort this stuff out. And the last one goes to 4843. That is Veneer. Congratulations. Okay, there we go. That is all our winners for this month. Claire will dish out the keys and the ranks as required, so keep an eye on Discord for a ping. Congratulations all. Right then, what was I doing? Oh yeah, so we need to convert this to that. So we got not a lot going on here. Yeah, we could do, I suppose. I've always gone with random.org because it's unrelated to us and cannot be accused of bias. So if we have something in game, someone could say, hang on a minute, that's fixed. Not that it would be, but you know, best to keep it as unbiased as possible. Right, okay, so we're setting up our input bindings there. That's just our setup stuff there. Oh, okay, so yeah, this needs changing. Yes, Madman. So both the engineering control room on the Magellan and on the Caravella will have terminals where you can access all the main breakers. Like on real world ships, you basically have like big banks of breakers and switches. Yeah, let's see if I can find a picture in a minute. forgotten how to use computers. There we go. Yeah, so generally in a real ship's engineering, like main engineering office, you've got the controls for the engines and everything, and you've got these main breaker boards that go like all the way down the length of the room, and this is where you can control pretty much everything. So whilst there might be individual breakers in situ, the main breakers are in here. So we'll do something similar to this, where we can control practically everything from a single room. Yeah, so the only reason you have to run around right now to do the cold and dark startup is simply because we don't have a central engineering room. But yeah, that will be coming at some point. I mean, in some cases, where you've got physical valves and things, you do need to run about the place, turning all those valves on. I mean, I've seen real world startups for various different vessels, and they do require a lot of running about. You're turning on valves, letting air out of things, doing air purges in hardware. It's, you can't just sit at a desk the whole time doing it. But yeah, there's definitely a middle ground there. Okay, so we need to grab a reference to that. So what we're basically doing here is we're setting up all of the usual stuff that we need to get a ship kind of represented in the world as a physical vessel that can actually fly around and go to warp and navigate the galaxy, as opposed to just an object in space which is replicating its position. So the physics test we did for the Caravella was more just a physics test, a bit bobbing around and firing its thrusters. We now need to give it the ability to actually go to warp. And at some point, we also need to make the vessel IDs dynamic. So right now we're giving the vessel ID an index of 2, and it will always be 2. But as we're spawning things like shuttles dynamically, say a shuttle gets destroyed, you 3D print another one, the ID needs to be dynamic. So we'll have to have a think on that at some point. But what we're doing here essentially is, for all the ships that exist in the game, shuttles included, almost everything included, so ships, stations, anything you can physically walk around on, we record that on game state in an array, and what we do is we just populate that array with the details for that vessel. So it's where they are in the galaxy, so which galactic coordinates they have, and then where they are within that 1 light year cube. So knowing this information, that means we can generate and rotate and position the skybox accordingly for each ship. So as you change between vessels, we can update the skybox immediately to represent that location in the galaxy. So that just kicks that off. So let's move that down here. Try and organize this a little bit. don't need that because it can already be hidden in game. Being that this is the physics version of our vessel, it needs to be basically at the world origin at the start of the game. So our physics ship basically exists at the world origin until the game starts, and then what we do is we then move that to where it actually is relevant to the 1 light year cube. So the mapping of coordinates is 1-to-1 within local space. Within galactic space we have a different coordinate system, but within local space it's all 1-to-1. That is until we condense it down. So we don't have that many issues with floating point errors, but something that's on the to-do list is to condense that local scale down to like maybe even like 1-to-100, so that we're condensing it 100 times smaller, so that we're having much smaller locational coordinates, which won't affect anything visually, but in terms of computing things, it makes life a little bit easier because the numbers are a lot smaller. Right, so that's basically telling it to start in orbit around Earth. So again, that's where Earth is in the galaxy, and that's a point in space next to Earth. Then we're spawning the proxy. Yeah, so I suppose this is different as well to how we were doing things before. So before, the proxy object is checking itself to see where it should be, whereas for the ships that we spawn, or for the objects that we spawn, we have them, like the physics thing, telling the proxy where to be, which is what we're doing here. So here. So basically at 60 Hertz we are updating the location of the proxy. So that's just what we're setting here. So we are positioning that in the physical local realm exactly where it is relative to the world origin, so that you can see it out the window basically. So if all the math lines up, then we should have the proxy object exactly where physics ship is relative to the object, even though you're physically at the world origin. There's a lot of confusing translation of coordinates, which always confuses me. So the first thing that we need to test just need to make sure that this holds true when we're not on the main ship. So when we go to the shuttle, this needs to update its coordinates. So let me just check that a minute. It should be doing its own translation. Ah yeah, there we go. So yes, it's working out what ship we're on and adjusting its location accordingly. So that's fine. The RCS thrusters are based on Vasmir rockets, so basically really highly accelerated plasma. Yeah, the fusion reactor is actually based on Tri-Alpha Energy's fusion reactor. I think their reactor's called Norman. Odd name for a reactor, but there you go. I think it's named after like their founder or one of their founders, something like that. But they use field reverse configuration, and I think Helion Energy are doing the same thing. I think basically it's the same principle where they're firing these FRCs at one another, and you know, containing that within a spinning plasma stream. Not that we've noticed yet in terms of performance. It's named after Norman Rostoker, or Rostoker. I don't know how you actually pronounce it, but you might recognize their reactor. Yeah, so that's Norman, which you might notice looks somewhat like ours. So the idea is that the FRCs are created and accelerated down these magnetic confinement chambers, and they're condensed down into like really compressed plasma streams, and then the neutral beam injectors are actually offset, so they induce spin, and it's that spin that keeps the plasma stable. So they're constantly like basically spinning that plasma stream so that the reaction takes place in the center there. That's how I understand it anyway. So our reactor design is basically based on that. Yeah, right, so setting up that, doing our RCS mapping, we've got our game states. Yeah, so we need to set up our loops. Nope, I have no formal background in anything like that. I just read a lot. Okay, yeah, so the only thing we're ticking on the actor is whether or not the thruster is actually firing. So we're constantly checking our thrusters array and seeing whether they should be firing or not, and turning them on and off as required. I might move this to an event-driven loop instead, rather than doing it on tick. Although that said, oh no, we can't, can we? Because we're applying an impulse, that has to be on tick. Otherwise, it will stop applying an impulse. The joys of moving to a physics-driven ship. Right, so that gets the galaxy bit done. The next bit we need is the warp bit. I won't bother with the game types set up yet. Basically, depending on what type of game it is, we put the ship in different places. Like if it's if you're loading a save game, obviously you want the ship to be where you left it. Right, so we need that one. Yeah, to be honest, we need most of this. So we'll grab all of that. Don't need that. Yeah, I want to recreate all those events. I'll collapse all these graphs once we're happy with them, just to keep this nice and tidy. Which I might separate that. So that's setting the ship locally where it needs to be. Yeah, so when it comes to planets and collisions and things, the reason that we haven't had collisions, and still won't for FTL, is that we're not moving the ship with physics. So in order for a ship to collide with something, you have to be moving it within the physics realm. What we're doing is, because the ship's going so quickly, we're simply updating its coordinates. So we're basically teleporting it like 30 times a second to get it to go the distances we need it to go. If we were trying to try to move it that quickly through physics, then obviously the physics would break down and fall apart, because you can't get the physics sim to go that quickly. So in order to stop the ship hitting planets at FTL, we need to come up with some computational way of doing that. So the ship's computer has to work out some kind of collision warning and automatically shut off the FTL drive when you get too close. I guess not unlike how Elite does it. So you emergency drop out of supercruise if you're trying to supercruise into something, probably for the same reason, in that it's not moving through physics, it's moving through coordinate updating. But yeah, so we'll just have to do a the computer goes, hang on a minute, collision alert, turn off the FTL, emergency drop, and then you are moving within the physics realm. Set up our mappings, set our game state, set where the ship starts, spawn our proxy, and we also have this. To be honest, might as well stick that in here. Just keeps all that in one place then. So we set up our array of thrusters, we do our mapping for input towards thrusters, and then we actually just enable input on this blueprint, which we don't need that there. So I suppose actually if we don't start with tick enabled, and then we enable tick once we've got our mappings set up. Yeah, so we won't enable tick until we've done all our setup activities. Yeah. The ability for other developers to work on core systems is really dependent on how well documented those core systems are. I mean, obviously, at some point, I want to be able to manage a full team working on different systems. We've got different core aspects to the game, from the ship sim to the galaxy sim. I want a team of developers that are dedicated to those particular sims. So we'll have a galaxy team and we'll have a ship simulation team, and they'll be working on those systems. So all of these core systems that I'm making now need to be extremely well documented so that in the future people can come into those documents, read through documentation, see how everything works, and when they actually come to look at the code, it makes sense because it's well documented and well annotated. And for my own benefit too, because there's many times I will go and look at a blueprint that I haven't touched in a year, and I'll just go like, why did I do that? Why is that there? Where does that even go? So yeah, that's like coding 101, isn't it? You always document everything as much as you can, because it doesn't matter how much you think you'll remember it. When it comes to it, you won't. When you look at something a year later, you will not remember why you did something. I'm taking this as an opportunity as well, actually, to just improve how some of this happens, because our FTL code is like 3 years old, and I've obviously progressed a lot since then, so I'm sure there's some optimizations that we can do while we're at it. Right, so we want our autopilot function, which we're going to have to fix a few bits on. I don't think those are actually used anymore. Though I think that one is. Because there's a few areas where a lot of prototype systems kind of stayed prototype systems. So where we're updating things like game state with some of the stuff we're doing, a lot of that stuff is probably better not being on game state. So having some actual manager classes that are actually managing this stuff. I mean, the reason I stuck it on game state is because obviously it's easy to replicate from there. That's kind of more of a convenience thing than anything else. Right, so yes, we definitely don't want that function. That's no longer relevant. I'm assuming that one still is relevant for now. Yeah, we've had a few people dipping in to volunteer on different things. I think when it comes to volunteering on stuff, obviously we can't just give people the source code to work on things. So any volunteer systems are things that are done in isolation. Like, can you build a C++ function that does this? Or can you just build a system that does that? People have helped with things in the past, like one of our moderators has made a few bits and pieces for the game in C++. So yeah, so we do take help every now and then. We just have to be very careful with that. Finding the right people, doing the right thing, and just bearing in mind that it's a commercial project. it's much easier to take on and manage volunteers for non-commercial projects, because it gets messy otherwise. Yeah, and like Dave Soft just pointed out, like back in the very beginning when we started, we did have some volunteers, and we got burned a bit because one of them decided he wanted to work on a different project, and then just randomly said, everything that I've done, you need to take out. So we had to strip out a bunch of stuff that he no longer wanted in our game because he'd gone to work on a different game. And obviously because he was just a volunteer, we couldn't say no. You know, there was no contract, he was just a volunteer. So yeah, so we're very, very cautious when it comes to volunteers. Any volunteer work that we have done will be very specifically contracted in the future if we go down that road. We'll set up the warp stuff in a bit. Let's just actually make the variables for now. So some of these will need their actual values. So what we're doing here is we are moving the ship through local space until we hit an edge of our cube, in which case we will teleport the ship to the opposing edge of that cube and increment the galactic coordinates by 1. Thus moving the ship through space. Suppose we'll set that to Earth while we're at it. No, not that one's correct, actually, that's the old one. Are we setting that on begin play, in which case it doesn't matter? Yes, we are. Okay, we'll ignore that then. So this is actually one thing that we need to have another round of tweaking. So the ship speed, where is it? So we're basically taking the input voltage, and we are working out how far the ship moves per 250 volts in this instance per tick. So the speed of the ship is directly tied into how much power is going into the FTL coils. That needs to be changed so that we're using the actual speed of the ship in Sublight in the direction that the ship is facing, and then we're multiplying that by a percentage based on the voltage of the coils. So it's going to be a lot more of an organic system, but it should be easier to compute speed, because doing it this way is quite confusing at times. Let's make sure we've got the right defaults there. So don't need those for a minute. Yeah, and I think also in some of these instances, rather than pulling out these values and storing them as separate variables, we'll just grab this data as is. Although, yeah, we're not using this anymore anyway, so that's actually somewhat redundant. So we don't need that. Do need this though. Right, so this is the system we're replacing. This is a plugin that we're using to handle ship movements, which is no longer needed. Yeah, so in every instance where we're using the plugin to move the ship to point at something, basically we need to override that and point the ship ourselves using the thrusters. So we shall rebuild that. Let's turn my heating off again. Actually, an issue we have with the autopilot right now is on the dev build, the autopilot is very wavy when it approaches planets. And that's partially due to how we're choosing to slow the ship down, but also because of this. So we are choosing when to turn the FTL off based on distance from a given target radius. So we're putting in the radius of the object and then obviously multiplying that by 100,000, which is so many kilometers, can't remember how many now, and basically saying, right, once we're close enough to the object, kill the FTL drive, but at the same time not if we're going too fast, so it has to slow down first. And also what it's supposed to be doing is it's supposed to slow down if we're not facing the ship. Yeah, so here, so we're trying to work out is the ship facing the target, and then the more we're not facing it, the more to reduce the throttle. So if you're 90 degrees to the target, the throttle should be 0. To make sure that the autopilot always controls its throttle when it's not pointing at something. So we need to go over this and update that for using actual thrusters. And I suppose a lot of the time we'll be coasting as well, because we'll be using the sublight speed of the ship to define the FTL speed. Some of the time the engines aren't even going to be on, because once we're going the maximum nozzle velocity, then we can shut the engines off and just coast. So yeah, it's going to be a lot of complexity there. Right, okay, so we should be spawning the proxy in the right place, and FTL stuff aside, we should at least be navigable. I'm not too bothered about the FTL side of things at this stage. I just want to make sure we can fly around and bump into stuff first. Yeah, so the fact that we've got the proxy ship on top of us is a good thing. It's where it should be. Yeah, we got a conflict there, so two things are updating where the ship is at the same time. Probably because we've still got the odd one there. Oh yeah, don't want that one. Only that one. Okay, so our proxy ship is directly on top of our actual ship. Okay, so that tracks. So we need to go and borrow the shuttle teleporter, because we need to test that both the shuttle and the ship are positioning themselves in the correct location with respect to one another. So if we pop that there, make sure we can get down to it. I think it just teleported me straight back. make sure these two teleporters are sending the pawn to the right place. Because I have a feeling they are not. So from the perspective of the shuttle, we should be able to look kind of down and forward and see the proxy. And instead, it's above us. So that's above us and facing the wrong way. And then the shuttle should be over there. So that's where we're putting it. They're not asteroids, they're potatoes. So I'm pretty sure the shuttle should be correct because we've got that working perfectly on the Magellan. So I'm assuming it's this one that's not correct. Actually, I will just check for other proxies. So we've got that one there. Right, so that's the actual shuttle proxy, and that's the ship one. So we don't want that one. Right, so that will get moved around as needed. And then so the start location on this one, that's yeah, so that's just above Earth. It should be well, it should be above the bridge on the Magellan. So technically shouldn't be back there. Right, so we're still seeing the same two proxies. So we know that proxy is right because it's literally overlapping the ship, so it's definitely in the right place. Oops, just got hit by a potato. And thus we know collisions are also working. Actually, what's that shuttle doing? So with respect to us, the shuttle should be stationary relative to the potatoes. I don't know why there's a disconnect there. So what's happening in these two different areas here is that all of the potatoes are updating their own position, like individually. So they're all tracking their own location, which is why they are all pretty much rock solid for one another. Now the planet, however, is twitching. It and the rest of the star system are all basically attached to a single anchor point, which is why I didn't want to do that moving forward. So I guess that's proof that the potato method is the one that's working. Because the potatoes are solid and the background is not. But it's good though. It proves that the plan moving forward is the right way to go, because they're a lot more stable, which is doubly impressive given how many of them there are. Now, the shuttle is still stationary, so it sees the ship rotating, which is what it should do. They're just offset incorrectly from one another. Okay, well, we will ignore the offset for now and just work on the controls. Okay, so now that we're updating game state with the location of the ship, it should move the ship with respect to the potatoes. So if I add speed, yeah, there we go. So we are now physically moving. Let me just see whether or not I have control over this from the keyboard. I do, so that's good. I need to remove those other camera views, actually. They do get in the way somewhat. Right, so I've got control of this now, which means we should be able to do our hugging of the donkey maneuver. So if I kind of back us out of the potato field a minute. Quite possibly. Okay. We're bringing a potato with us for the ride. So we're now flying the ship with actual physics rather than artificially setting the position of the ship arbitrarily. So the thrusters mean something now. Just need to make sure that the the mappings are all set up from the helm. We definitely have... Yeah, that's exactly what I'm doing actually. I'm using... Well, I'm not using WASD, I'm using a numpad. That is A and D, moving me left and right though. And then that's pitch. And, yeah, pitch is W and S. We can't use Q and E for roll because we use those for like unlocking the mouse and such on the helm. I don't think I set up plus and minus for speed on the helm chair, but we do have pitch, roll and yaw, which is nice. So in order to successfully hug the donkey, or hug the potato, as we will do in this case, we need translation controls left and right. I don't think I've got that yet. I think that's, yeah, so the cursor keys, WASD and numpad are all pitch, roll, pitch and yaw even. I think one might be moving us left. Let's get speed sorted out a minute. In fact, let's just check to make sure that we don't have it before I go and change anything. So plus and minus do nothing right now, so that needs adding. 1 and 3 do nothing, so we don't have translation controls. I might move translation onto the cursor keys temporarily, because then we've got left, right, up, down. So 7 and 9 are working for roll, 8 and 5 are working for pitch, and 4 and 6 are working for yaw. Okay. And it is nicely fully Newtonian. Right, so we need forward and back, and we need translation on the cursor keys. I'm not sure whether we even have that as a mapping context, so let's just check that first. So if I remove up, left and right from yaw, keep those. Right, so throttle plus we do have mapped. Right, so what we don't have is translation. So we need translate left and up. Yeah. Last time I saw Flight of Nova was a long time ago, so I'm going to have another look at it. I mean, ultimately we want HOTAS set up, so we'll be using that in the long run. Yeah, so we're inverting those with the opposing keys. We'll probably do the same with these as well. I do have a controller actually, hang on. Should be plugged in. Is it plugged in? Follow the wire. Where's the wire going? Nope, it's not plugged in. It is now plugged in. So it doesn't help that we immediately got hit by a potato. I'll reduce the potato field. I'll have to give that a try, AJ. Okay, so using the controller, move the camera around. Oh, I hate controllers. Okay, so yeah, so that's pitch on the controller, yaw on the controller. Yeah, and the other thumbstick is controlling the character's head. That's zoom. Yes, we don't have roll controls. I shall have to think of the best way of doing that. Maybe shoulder buttons for roll, but it's a difficult one. Yeah, that's what I was just thinking, that the shoulder bumpers for rolling, because we've got, obviously we need to be able to move the character's head, so we can't use the other thumbstick for rolling. Obviously we'll make it all mappable anyway, so you can change it, but because you need to be able to look at controls and press buttons and things. Yeah, they are actually potatoes. Speaking of which, though, we want less. Let's do 1,000 rather than 2,000. Yes, we are actually spawning potatoes. Look, potato. So if we're actually sending throttle, oh, I bet this is going to be like the FTL throttle, not the ship throttle. And that's the other complication. So we need FTL power and ship throttle separately. Let's do that actually. Yeah, so we have throttle, and I'll rename those. I'm not going to rename them yet because it will break something down the line. But I'll change those to FTL field strength up and down, and that's the actual ship throttle. It's really annoying with these that whenever you change something, it expands them at random. How is that helpful? So we want keypad plus and also minus. And I need to remember how to negate them. It's going to be a conflict here, but oh, it's just literally just negate. Okay. Right, so that's forward and back. Throttle. Oh yeah, then we want translation, don't we? So left and right. Right has a gate on it. Then we also want up and down. So translate up. No, not left, up. Stop scrolling to the top. So up would be up. Down will be down. And that one is negated. That one is not. Did I just overwrite translate left? I think I just did, didn't I? Right, okay, so up, down, left, right, and then we just need to make sure that we map that on here. Okay, so we're mapping our helm inputs to a integer, and then we are just translating that on here. So we've already got main forward. We should have main aft as well. Might be nice at some point to replace that with an enum instead, just so we're not having to kind of remember which integer corresponds to which thing. And then we need to know what the chair is doing when we're sat in it. Right, so we're enabling helm controls. Right, which is actually on player controller. So enable helm controls, blah 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 blah. So that basically clears all our mappings, which we're going to not do now. So we'll just skip it because we were using that with the 60OF plugin to make sure that we clear any inputs that might be running. I might just change it to 99 and do it that way, but we'll probably need 10 for something else. Okay, and we should have some mappings on here. Evening. Okay, so we're adding our mapping context for the helm, and I'm sure we're not doing it on here. No, definitely not. No, we're not doing the inputs from here either, so it must be coming from here. So somewhere we have input mappings that are being translated to helm inputs specifically. And I'm just trying to remember where I was processing those, because because we're getting them as a global input on the helm channel. Hang on, let's look at the reference chain for this. Yeah, so these are the only blueprints that actually reference that. They can't be coming from the player controller, I'm sure. Oh, right. Yes, I remember now. So, yeah, so this is another one of those things where the system has been implemented and it works, but it needs refining. So this is happening from the Helm UI. So what we're actually doing is we are, when you use the controls on the keyboard or the controller, we're getting the UI to press the corresponding button. So basically you're just pressing the UI button remotely, and then the UI is doing all the ship control stuff. So all of that is being processed on the ship UI. And so the decision then is, does that make sense? Does remotely pressing the UI buttons make sense from a game perspective, or should we be sending those controls directly to the actual ship itself? Or is routing them through the UI the correct proxy and the correct way of doing it, because you are basically simulating having reached out and pressed the button? One benefit from using the UI is it means we do actually get like the UI response, and like we can flash the buttons and things as if you'd press them. But yeah, that's kind of a question to ask. Well, that's interesting, League. Yeah, I think it's I've mentioned it before. What I like about working with blueprints is that you're working with a flowchart, so you can logically see how things link together and how logic progresses, because it's physically there in front of you. Which, if you're writing just raw code, you can't see visually how certain things are flowing from a logic perspective. Yeah, that was kind of my rationale when I set it up originally, is that you are sat at the helm, and you won't be flying the ship from anywhere else. So having the player inputs routed through the UI seemed to make sense at the time, because that's what you're like. Pressing the keyboard or a controller is kind of a proxy for pressing the UI button. Where are we? So it would be that one, I think. Oh yeah, definitely. Yeah, HOTAS support is very much on my to-do list. Okay, enjoy. So the enhanced inputs are, so when you press the use sensor target button, it's basically firing this event. if you use the keyboard, it's literally doing the same thing. So we're just having the keyboard input just do exactly what the physically pressing the button does. Yeah, I think the way we'd have to do that, Anasi, is once we have a secondary bridge set up, i.e. the engineering control room, there's going to have to be some kind of a handoff. So, you know, if control of the ship or management of the ship is being passed to the engineering control room, then there needs to be some kind of switch that takes place. So there'll be like a UI control or some kind of physical switch that shuts off the bridge control and transfers all of that down into engineering. So you can't have both running the ship at the same time. Yeah, true. Right, actually, so that particular widget is the left-hand one. We want the middle one. Yeah, so we're doing the same thing here. So our enhanced input is doing exactly the same thing as pressing the physical buttons, and then we're sending through our control mapping as to which interface we've pressed. So if pitch, roll your speed up and slow down are 6 and 7. We do actually have, oh yeah, these ones. So 13 is that one. Now on 11. Oh no, sorry, 12 and 13. So 12 is backwards, 13 is forwards. So on here, hang on, let's get rid of some of these superfluous tabs. So what was 6? Because that doesn't seem the right one. So that was the speed up button on the helm. Okay. So 7 then is the opposite of that. So, oh yeah, main aft. So 12 and 13 then should do the same thing. Hang on, let's make sure that we are actually able to do that. Oh, doesn't help that we've been rammed by a potato. That's essentially exactly what's happening, Madman, yeah. There we go. So we can go forward, but not backwards. Or can we? Perhaps we can't go forwards. No, we can't go forwards. Okay. So we're definitely firing that. So 12 is aft, 13 is forward. So 12 aft, 13 forward. So if we add the other input action in there as well, so that was helps if you spell it right. Helps if you get the right event. So I'm just going to let's replace that one a minute. Yeah, it's all done through enhanced input. I've got a few manually assigned ones, but not many. Okay, yeah, so plus and minus aren't doing anything, but we can do it via the UI. Interesting. So if the UI is working, then how come that isn't? I wonder if it's because we've got a duplicate mapping on here. So if we get rid of throttle a minute and just keep the existing one. Ah yeah, that was it. Well, I say that was it. It fires once and then never again. Okay, interesting. Orbits will be handled very differently, so we'll just have to move everything in space sideways at the same speed as they'd be going at if they were in a spherical orbit at that altitude. So it's all based on altitude versus sideways motion. And then we also need to calculate the inclination of the orbit based on distance above the equator. So equatorial orbits will be inclination of 0 in a circular orbit, and then the speed of the orbit depends on altitude, and then the more towards the pole you go, the more the orbit will incline as you go towards the pole. If you're at the pole, it will be an inclination of 90, so you'll be doing a polar orbit at that point. That's basically how we'll do it, but the math involved in doing that is going to be interesting, because we're going to have to move every single physics sim object sideways. So we'll be using basically teleport, so we'll be teleporting it at like 30 times a second sideways in order to complete an orbit. So the relative positions between everything needs to stay solid whilst we're moving the physics state sideways. So it's it's going to be challenging, to say the least. And if it turns out to be really, really, really janky, then we'll have to come up with some other solution for it. Yeah, I think if moving the physics state of everything sideways doesn't work, then we'll have to move the visual galaxy instead. So we're literally dragging the galaxy around the planet, and then obviously move that accordingly when you warp away. Well, we'll try both and see which one's the most performant. I've not actually tried playing with FTL in Space Engine. I just scroll around with the mouse. Yeah, well, by virtue of the fact that the speed you move sideways depends on your altitude, geosynchronous orbits are just naturally occurring, because every planet has a geosynchronous orbit distance. You just need to be at the right altitude. I don't even know what a cane function is. I'd have to Google it. Okay, so they definitely work. I wonder if we're not sending button down. That would cause an issue. actually want to open that. So we're definitely broadcasting button down. So I'm wondering whether or not it's not receiving a button up. So it means that as far as the ship is concerned, it's continually thrusting. Or yeah, because if it's pressed, then we're sending firing. So I suppose actually, so yeah, so when we release the key, it's no longer triggered, is it? Okay, well let's start by trying to go backwards instead of forwards. It sort of works like that in this cloud. So the way our FTL works is that the FTL field doesn't move the ship anywhere. It condenses the space ahead of the ship. So you still require some kind of thrust from somewhere to move the ship through that condensed space. But the FTL field itself isn't applying any kinetic force to the ship. So the field is obviously compressing space in front of the ship, and that depends on which way the ship's facing, because the field will move, depending on the ship's orientation. So in order to achieve the best speed with the FTL, the field needs to be aligned with the prograde vector of the ship. So if you rotate the ship, and thus the field, away from your prograde vector, the compressed space that you were moving through is now like over to your left somewhere. So as the field rotates, the space in front of your movement is becoming less and less condensed. So the FTL works by compressing that space that you're moving through. So if the speed and the field direction are aligned, that's your maximum FTL velocity. If that makes sense. It sounds similar. I don't know why you'd need to be pointing at Sat-J, but yeah, that's how it works in our game. Okay, so yeah, I think exactly what I feared is happening there, in that we are continually thrusting backwards, because we're not saying that the input has been cancelled. So is that the same for the other inputs? So if we do roll, oh no, we're not sat in the chair, are we? That would help. So if we roll left, no, so roll is not constantly firing. If we hold it down, it does, but then it stops when we release. Okay, I'm assuming pitch is behaving as well. Yeah, so both forward and backwards are continually pressing. I wonder if it's something to do with how they're set up on here. So that's just pressed. Okay, so that doesn't have a trigger, neither does that. Okay, so let's get rid of the pressed trigger. Why is it not saving? Oh, probably because it's open in Visual Studio. There we go. No, try again. Okay. Right, yeah, so I guess we are doing something similar in that like zero, like galactic north is between Earth and Sag A, so that's where our north direction is. So our X vector is towards Sag A. Speed-wise, I guess we're doing that based on distance moved. So when we're not comparing distance relative to Sag A, we're comparing just distance in galactic space. I suppose we're assuming perfectly flat space-time around the Milky Way to do that, but I think for the purposes of a game, that's probably sufficient. How very odd. Okay, so there's our input mapping, or input action rather. I'm assuming it's something to do with that. Okay. Is it that? Yeah, so plants are not spawning because I've changed the way the services spawn. There's some calculations it goes through to work out where like sea level is, and because we're spawning the terrain like way below the ship, where it thinks sea level isn't. So I just need to go through and kind of realign the numbers. But yeah, the terrain system is very much in its infancy, so that's not going to be working properly anytime soon. Right, so in order to work out whether or not this is an input issue or a thruster issue, and it can't be a thruster issue actually because it works on the helm, doesn't it? So it must be an input issue. Yeah, let's just double check that a sec. No worries. Right, okay, so this is definitely working fine from the UI. So what are we sending from the UI then? So that's okay, yeah, because we're sending on released as well, and they were telling it that we're not pressing the button. Right, and then we're sending completed to say that we've released the button. I think that's what we're missing on this side. We're not sending the released message. So as far as it's concerned, the button's being continuously held down, which is not what we want. So we're doing triggered and completed, triggered and... Right, so we need the completed pin for throttle. Okay, a tad messy, but that should be problem solved. There we go, now it works. Oh, saying that. Forward worked. Now we are flying backwards, out of control. Okay, so just make sure that we can do that. Okay, and then forward and stop and backwards. Yeah, so backwards isn't sending the cancellation. Okay. Oh, I see. Right, so when we release, it's not sending the action value, which is why I was using a sequence, so that we don't want to check to see what direction the button's in, because it's always going to send 0. That makes sense now. So forward, backwards, forward again. Great. Okay, that's working now. So we should have fairly decent control over the ship now using the RCS thrusters. So I guess the next thing we need is those translation controls so that we can like null out lateral movements. And to be honest, we could also do with unlocking the camera from the ship so that so the chase cam is not quite so like solidly attached to the ship. And we also need to get that proxy actor to show the visible thruster firing as well, because obviously those physical thrusters are firing on the main object, but not on the proxy. Yes, the shuttle will be pretty much the first thing to get the full working version of this. No, there is no real world logic or justification for having a chase cam. That's purely a game thing. I mean, you could probably pretend there's a drone camera following the ship everywhere, but no, it's just there for the sake of it, really. It's there for screenshots and for seeing the ship from the outside. Okay, so we have control, which is good. So in order to perform our hugging the donkey maneuver, we need to be able to strafe the ship whilst yawing the ship and also accelerating forward at the same time. That will allow us to basically orbit an object whilst keeping the nose pointed at that object. We're kind of almost doing it there with that potato because we've got some lateral movement anyway. But yeah. Right, so we need to add a couple more input mappings on here. So we're up to 16. So I think we're at the point now where when we do our next pass on this, in fact, when we do the actual proper Sublight update, we'll change all these IDs into actual enum values, because it's getting silly at this point. So we'll translate, oh, not that one. Translate left, translate up, check that we have power, and then we'll make sure that so the reason we do this check here is just to make sure that we're not currently entering or exiting warp. Basically that just locks the controls. And then the last one is whether or not we are doing a positive or negative value. And then we also need our cancellation, which we'll do in a sec. So we've got 17, 18, 19 and 20, and then cancelled versions of those. Okay, so those are our inputs from the input action. And I think we used to have like up down on here as well. I must have got rid of them at some point. I'll put them back in, but yeah, we should have up, down, left, right, and also forward and backwards as well. So we can use the RCS to move forward and backwards rather than the main engines. Ultimately, you don't want to be using the Sublight engines for precise maneuvers around a dock. Evening. Yeah, the shuttle needs to go through a couple of bits of development in order for it to land on planets. So challenge number 1 is be able to enter the shuttle. Now, in order to do that, the proxy actor for the shuttle needs to have the teleporter on it. Now that's if we're going with a static shuttle interior, and I'm kind of toying with the idea of not having a static interior and actually having the physical model of the shuttle be the thing that we move around. So we need to have the shuttle its own space object, which is held in place when it's not within something else. So if it's not on the planetary surface and it's not in the hangar of another vessel, then it needs to essentially be locked in position at the world origin, and we move space around it. As soon as the shuttle enters another environment, then the inverse of that needs to happen. So the object that it's inside is locked at the world origin, and then the shuttle is free to move around within that object. And again, that could be a planetary surface, it could be the hangar of a space station, or the hangar of a ship. When you fly out of the doors of the hangar, or you fly out of the atmosphere of the planet, we need to do that transition where the shuttle is then locked in place and space moves around the shuttle and everything else around you is now a proxy. So when you exit the shuttle bay of a ship, that should happen instantly, and other than maybe a small hitch, you shouldn't notice it happening. Space will already be in the right position relative to the hangar, so that's fine, so you won't notice space moving. And because the hangar is going to be behind you when you're flying out of it, you shouldn't notice that change to a proxy object either. So the whole thing should be pretty seamless. And because we're not teleporting the player through a teleporter into a static shuttle interior, it means that we don't have problems with people, say, carrying an object using a physics handle, because then we'd have to teleport the object through a portal at the same time as the player, which would probably break the physics handle, and then they drop the object, and there's a lot of complexity involved in doing that. Basically, we're kind of rewriting the game Portal at that point. So it's easier if we move the shuttle around. So in order for the shuttle to leave the hangar and get to a planet's surface, we need to go through those steps where we're swapping out proxies, where we're triggering the teleport to take the shuttle down to the planet's surface, and there's a lot of steps that we need to go through and a lot of things we need to build and develop in order to get that from A to B process complete, and then obviously have it work in reverse on the way back as well. So yes, having the ability to fly a shuttle around is only part of the problem. Getting it to the planet's surface is a much bigger problem. But as I say, we have a plan on how we can do it, and we have 2 different ways we could do it that work within our engine. So it's just a case of getting there, really. There's a lot of stuff on the to-do list that will probably be coming before that. Ah, you missed my naked dance binary. Oh, that's a shame. Yeah, we don't want to cop out and use transporters. Great minds, Claire, great minds. Yeah, we will have teleporters, but they're not going to work like Star Trek transporters, or even the Stargate version. So what doesn't make sense about transporters is essentially everything. Nothing about them makes sense. Nothing about them is kind of scientifically sound. But we can probably do something along the lines of maybe squishing objects through like a micro wormhole or something like that. So we're doing something with matter that's moving the physical matter. It's not reconstructing that matter somewhere else. So they're not like murder machines like they are in Star Trek. We'll think of some way of doing it. Yeah, a magic door. Yeah. And it'll be like line of sight only. So one of the issues with the likes of Star Trek or Stargate is their transporters always work like through solid rock, and you can transport someone like deep underground. So if we do put teleporters in, and I'm sure we will at some point, they're definitely going to be like line of sight, point to point only. So you'll need to be able to shine some kind of matter beam at the location that you're teleporting to. And if something gets in the way of that beam, then obviously that's blocking the ability to teleport. So something like that. There will be law and rules around how it works. Yeah, I mean, FTL, it's a difficult one, isn't it? Does FTL make scientific sense? The math says yes. Like, all the papers that have ever been written on it, from Alcubierre's to Lentz's to Harold White's, all those papers are mathematically sound. So, from a mathematical, scientific perspective, FTL travel is completely plausible within general relativity. The argument comes with the fact that you need negative mass in order to expand space, and the fact that you need like massive amounts of power, and the question as to whether or not it breaks causality through time travel. Now, my argument is that it does not break causality because the occupants in the FTL field are in flat space-time, and clocks do not tick any differently from outside observers to people within the field. All you're doing is moving the ship through compressed space. So you're not dealing with any relativistic effects because no one is moving relativistically. You're simply picking up a bit of space and putting it somewhere else. And space itself is expanding faster than the speed of light, which is why we can't see the edge of the universe, because it's moving away from us faster than the speed of light. Or rather, it's expanding faster than the speed of light. So we know space can be compressed because black holes exist. We know space can be expanded because the edge of the universe exists. So, like, all the math works. So within math, it's plausible. Yeah, so you need negative matter as part of the equation. So one of the reasons, I guess, exotic matter needs to exist in order to make FTL possible, or at least to make an Alcubierre field possible, because compressing space simply requires positive mass. But to then expand space, you're basically creating a white hole. So you need negative mass to expand the space. That's how I understand it anyway. So positive mass compresses space, i.e. a black hole, and then negative mass expands space, i.e. a white hole. So you've basically got a black hole ahead of the ship and a white hole behind the ship, and that's your balanced field. Ah, good question. But yeah, I enjoy talking about it, so it's all good. But yeah, so we need to turn our math problem into an engineering problem. Yeah, thanks for attending my TED Talk. So have we actually mapped up, down, left, right? No. But we have got left and right, so let's see whether they work. And whether or not we... Oh no, potato in the way. Yeah, definitely, Jamo. I need to remind myself what was in them. Okay, so we've still got pitch coming from the cursors. Thank you. Yeah, well, Dr. Eric Lentz wrote a paper with novel geometry to the warp field, which supposedly removes the need for the negative mass side of things. So, obviously, I don't know. I mean, it's a peer-reviewed paper, but I don't know the overall upshot on whether everyone agrees. But if his paper is correct, then you can avoid the negativity problem by simply changing the field geometry. But the most recent paper on it was actually last year, like a few months ago. I think that was Dr. White. And I think he proposed essentially warp nacelles. So he was saying that rather than having a ring around the ship, if you were to have discrete nacelles instead, then you're reducing the power requirements because you're not having to power an entire ring, and you're basically just making the same thing possible using more efficient techniques, which kind of ironically puts it closer to Star Trek. I think it's about the balancing of the field jack. So I think you need to expand space behind as much as you're compressing it ahead. Like, it needs to be a balanced equation. But I mean, I don't understand the math of it at all. I'm just going by what I've read. So translate up, no trigger, the modifier for negate, translate left, negate, no modifiers. Just has down. That also just has down. Okay, so they should be set up as needed. But then I noticed we had a problem with pitch. Ah, yeah, there it is. That one. Right, so that should free up the cursor keys. So up, down, left, and right. Obviously down and right both have negate, so they should send a -1. Okay, so -1 would be 20, so that's down. And -1 will be 18, which is right. Right, let's just skip those checks there a minute. In fact, let's skip all the checks just so we are only dealing with the raw values. Right, so we're sending the value to there, sending the value to there, broadcasting it there, which we are then receiving here. sure that we are in fact sending through the values we want. Potato whacked. Have a good one, Madman. Okay, so we're definitely sending the inputs. Okay, so we are moving sideways, but not very quickly. Remember, you can press F1 in game and report bugs that way. I need to go through Mantis and sort it out because it's got like the public account for some reason has become locked, so I need to fix that. But yeah, you can report bugs just by pressing F1. So I think the issue here hang on a minute. So we've got duplicates of left and right. No matter. So we need to make up-down versions. But I think the problem we had with these was the problem of force. Let's just try it a minute on the UI. Because the forward and aft thrusters aren't exactly the same distance from the point of the center of mass, they do rotate the ship slightly when you try and translate left and right. Yeah, so that's working. Okay. They're not. Okay, so why not? Oh, I see. Because no, the wrong way around. That would be why. Okay. So we definitely went that way. And we've hit a potato. Okay. So I didn't want to go back the other way. Okay, so we're triggering, we're sending 17. Negative value, we're sending 18. Then we're clearing those off. And then we're sending 19 and 20. Cancelled, clearing them off. Should it be on complete rather than cancel? Oh yeah. That'll be why. It's always something simple. Okay, so we should be able to now navigate. Oh, I've got my left and right inverted, but we are turning. Not very good at avoiding potatoes, apparently. So the test for sublight control was, of course, that whole hugging the donkey maneuver. So it was the ability to strafe whilst turning, so that we can strafe around an object. Because you also have to sort of thrust forwards while you're at it. So we should be able to sort of orbit around a potato like this. Which we're kind of doing. I think we're about to hit a bunch of potatoes, but still. So this is where we need the up and down thrusters as well. Right, okay. So it would be nice to have the visible thrusters firing on the proxy mesh while we're doing that. So we were like just about hugging a potato there, and I think actually if we have less potatoes, that will make life easier. Maybe take it down to 100. See how many that is a minute. That looks far more sensible. Hey, Grimlock. Okay, so without up and down to worry about, actually the shuttle will do. If we sit in the helm, doesn't it? Get out of my chair. Exactly that, Jamo, yes. Hugging the donkey potato style. So in order to successfully hug the potato, you need to be able to be thrusting forwards at a constant rate, whilst also yawing the ship and translating sideways. Right, we're above it, but below it rather. So if, oh, no, wrong button. So if we now go sideways and yaw, so from a combat perspective, this is the kind of maneuver where you would use this to maintain station on a target, but always having your guns to bear. So if you can just rotato around your potato, then you're always obviously facing it. So the faster you go, the more you need to thrust forwards. Yeah, we're kind of getting beyond the point of the ship's yaw. Oh, losing it. But yeah, so if you can imagine shooting guns at the same time, that's basically what we're doing with it. So ship combat in the game is kind of going to be a bit like this, where you are constantly trying to keep your guns on target whilst staying out of the way of their guns. I just thrusted forwards way too quickly then. Don't hit the potato. Oh, I hit the potato. And I hit the shuttle. Oh, bad piloting. Yeah, so the translation thrusters aren't very strong, so I think that's something that needs looking at. Yeah, the shields are going to be non-Newtonian fields, basically. So the idea is the faster they get hit by something, the more solid they will be, whereas slower moving objects can just push through them. So like a shuttle docking can just like push its way through the shield, whereas an incoming projectile would bounce off. Right, so we need to do up and down, and we also need visible thrusters. So these, so 17 and 18 are inverted, and these probably will be as well, but we'll see. I think if we I guess just use the pitch mapping, because that contains all the thrusters that we want. And then we need to remember what they actually were, which was this lot. So starboard aft up, port aft up, and then we want that one and that one. So for simplicity's sake, I'm going to just copy that, just so I've got a map in my head. So we want forward, port and starboard up. So port forward up would be 8. Hang on, this is up, isn't it? So we want the down version. This is where I got confused last time. So to go up, you need to fire down. So port forward down is 9. Starboard forward down is 11. Right, so they're right. So we need the opposite of these two. So port aft down is 13. And then port starboard aft down is 15. And I guess 8 is up, 10 is up. Right, so I just need to minus 1 from all of them for the opposite one. So that would be 8. 10, 12, and 14. Because we're just firing the opposing thrusters to go up and down. Let's see whether I mapped them the right way. Yes, like the go aboard personal shields, exactly that. I've not had a chance to play with it yet, no. I'm not sure whether you're aware, but I actually co-founded that project. But no, I've been so busy with this, I have not actually had a chance to keep up with it. Okay, we are going up and down, but I have a feeling we're also kind of pitching and yawing a bit while we do it. Yeah, so I think we've got the same problem with this that we do with translating left and right, in that the because the thrusters are not an equal distance away from the center of mass, it's causing a bit of pitch at the same time as going up and down. So we need to balance that out. I need to probably come up with a percentage of thrust difference. There's probably a way of mathing that out, but yeah, definitely needed. But we do actually have up and down, so we've got up, down, left should be going left now. Yep, so that works. And obviously our rotation is a lot more performant. I'm quite sure we've got the same thrust going through the thruster, but it's a lot more responsive with the pitch and the yaw compared to the other axes. But we'll tweak that obviously and make it the same. I guess what we'll have is a set power profile for all the different modes of movement, and then we'll have a modifier. So if we can get the percentages kind of as precise as possible, then we can just modify using a global modifier and then change the overall ship responsiveness without having to fiddle with each individual thruster separately. Yeah, it makes sense, Jamo. Yeah, so if we actually so the Caravella will be coming out as part of the Founders Edition of the game. So hopefully Christmas 2026, so 12 months from now. Obviously it's not finished already yet, so we probably won't make it available publicly until it's like properly polished. But our Admiral level backers will get it much sooner than that. Well, basically, as soon as it's flyable and actually usable properly in the game, then we'll stick it out on a dev build for Admiral level backers to play. We've already sorted out being able to start a new game using it, so it's just a case of we need to collect the Steam IDs of the relevant backers, and then it will be available to them. It is technically already in the game. Yeah, we'll have something like a flight controller, definitely needed, and because one of the things that we'll have is dynamic power capability per thruster. So if one of the thrusters gets damaged, then obviously the other thrusters either need to turn down or turn up to kind of cope with the difference in thrust that's being provided. So ideally all of that needs to be managed on the fly. So there's a lot of complexity there dealing with different rates of thrust over time. But I don't think, I don't foresee us getting it perfect, but hopefully good enough will be good enough. What was I going to say? Right, so when we set up the physical thruster, we're doing that on our simulated ship. So this actually has all of the thrusters there as static meshes, and we're deriving the location of thrust from the position of these static meshes on the ship. So it is thrusting genuinely from that position in that direction. So what we need to do is take the same position and spawn a graphic on the proxy, and then get rid of said graphic when it's done thrusting. So I suppose what we'll do, because we're using a generic actor for all the proxies, and if we can keep it generic, all the better. So if we do it from here, because we've got a reference to our proxy, because we can add actually, so just thinking about the way we're doing this, so this is constantly firing. So we don't want to be constantly adding proxy objects. So yeah, so we do actually need to show and hide them instead. So I suppose, so if we know, because we've got an array here of thrusters, and we know whether or not they're firing because we're setting that in the array, and then what we're doing, where is our event graph gone? So what we're doing with the tick event on here is we're firing or not those thrusters based on that array. So what we could actually do is we could get our proxy, and we can update the same array on the proxy, and then it can turn its visible thrusters on or off accordingly. That said, I do believe the tick rate is 0, so it's going equal to the frame rate, and we don't need the visible ones to tick that quickly. So if we do a new timer for that rather than doing it on tick, then we can do it a lot more slowly. Yeah, to be honest, like every 10 milliseconds should do it. So update proxy. So if we have a function for update proxy, of course we won't have that in the world anymore because we're spawning it from here. The center of mass is calculated automatically based on the collision mesh. So it's something that Unreal does. I don't want it to do that, so I need to find out whether I can override it. But by default, that's what it does. So on our mesh, this one specifically, if we look at collisions, so right now we're just using a capsule collision like that for the ship. So what it does is it calculates the center of mass based on the center of this shape. Now if we were to do away with that, then we end up with an unbalanced collision. So if we remove that and do auto convex, and we just like whack all this up to maximum. Right, so it now thinks that this is the most efficient collision shape for this mesh. Now, what it's going to do is it's now going to move the center of mass further backwards, because a lot of the collision geometry is clustered around here. So that's where it will think the center of mass is. And obviously this is when I do it properly. Obviously I want a collision mesh which closely hugs the profile of the ship so that you can fly shuttles through it and such. But unless it's exact, then it does give you an offset thrust. So I found that, well, I shall demonstrate. If we now try and fly the ship, its handling characteristics are very different. The Caravella is the same size as one of the Magellan's engine pods, so quite a bit smaller. Forgot to get in the chair. Yeah, so the center of mass has now changed on the ship, and we're now rotating around the engines at the back rather than the midpoint, which is where that kind of window is in the top there. That's where it should be. But it does mean, accordingly, that we do now have proper shaped collisions. So if I kind of oh yeah, so case in point, if I try and apply forward thrust, then the ship is thrusting sideways like that, because the thrust profile is offset, so I can't go forward and backwards without the ship spinning. So yeah, so until we figure that out, we will have simple capsule collisions for now, because at least that's balanced. Okay, so what I'll do is I'll make a child class of this proxy object where we can spawn in all the thrusters. So on our update proxy loop, grab our proxy. And we will just set the variable accordingly. So it now knows what thrusters should or should not be firing. So what it can then do is it can be just constantly checking that array to see which ones are firing or not. So if we just do an is ship boolean on there. So if is ship is true, then we're going to loop a function which is check thrusters, and that can be going at 30 hertz. Check thrusters. So we will grab that, go through all the thrusters, I think we'll do a setup event where we spawn them, because I don't want to be constantly adding and removing them. Yeah, because that would suck. So we don't want to do that. See, the issue here actually is we don't have a direct reference to which one is which. So really we need, I guess we need a map instead, because if we have a vector and a boolean, then we just need to know, do we have something at that vector which is currently firing? So yeah, so rather than looping this, yeah, let's make a map. So we need a vector with boolean. So it's a case of are those vectors firing? I suppose the other thing then actually is we need to the thrusters are fixed. Yeah, making them movable would induce a world of headaches. I guess, you know, in the long run, there's perhaps no reason why they couldn't be movable, but yeah, at the moment they're very much fixed. I mean, having thrusters that can gimbal would definitely give you more control authority. But yeah, we'll have to look at that for the future, I think. So the most performant way of doing this would be to do a single setup event where we add all of the thruster graphics that we need and then hide them all. And then whenever we update this, then we turn those on and off rather than adding them and destroying them, because that's going to just create loads of like garbage collection and all sorts of other stuff. So that being the case, I suppose we need to, rather than updating it with that, we need to create something when we do our initial setup. So when we do this, so we're already assigning them to a set array. Does that match? I guess it doesn't, because I'm just thinking we're sending through control surface inputs, but then obviously that doesn't need to map against one of these because each control surface fires multiple different thrusters. So what we would have to do is build a second array where we take the vector, the relative vector of each thruster, and then assign that a Boolean. Or what would probably be easier is just to add the vector to this. To be honest, that might speed up the tick as well, so we're not having to get the vector every time. Probably argon for these thrusters. It needs to be something non-volatile that we can just turn to plasma and accelerate. Yeah, I think in the grand scheme of things, it's probably going to be easier just to track the vector of the mesh. Now, I think the reason that we're even tracking that in the first place is that so we can show and unhide on the ship. We don't actually need to do that, so having a vector probably makes that redundant. So we still need to spawn once and then update many. So we need a way of comparing. So I suppose we could compare vectors. So either we use the vector as an ID, or I suppose it doesn't make much difference really, does it? Because we need to get the child component on the proxy. Have a good one, CSI. I suppose the other thing we need to know actually is which way it's facing, so it's probably better as a transform rather than a vector. So we need to do transform on all of those. And then when we do our loop, let's get rid of a bunch of this a minute. Right, so when we manage thruster, we're actually getting the location and rotation from that, and then setting the visibility of that. So that's no longer relevant because we're not showing the visible thruster on this mesh. So really what we want to be doing is adding the transform onto there. Really we just need the one input. So if we change that to struct RCS mapping, so location goes there, rotation goes there. Firing goes there and there. And force goes there. So then we no longer need that or that. Which means that is now irrelevant, so we don't need that anymore. So that cleans that up a bit. But that does mean on here, we don't need that, we just need to do that. So this is going to be nice and tedious. Yeah, all of the consumables aboard the ship will be acquired through skimming gas giants. Gas giant atmospheres are packed with most of the stuff that the ship will need. This is the glamorous side of game dev that no one tells you about. Just mindlessly typing things in or connecting pins. Okay, so we've got a transform of every single thruster location, so we know where all the thrusters are. So on there we need to get rid of that because it's no longer needed. Okay. Again, that simplifies our tick event. Okay, so we're updating that same information on the proxy. Which so we have this information available to us. So the question is what we're doing with it. So we can use force to drive our effect, like how bright or how large the RCS thrust is. So if we're using like a HOTAS with analog input, then we can use the amount of force from the analog input to drive the size and the brightness of the effect. So that's available to us. Obviously, whether or not there's a force at all, that's there, and that's where we'll actually be firing the thruster from. So yeah, so we do need to still go through our array of thrusters, but I'd like to set them dynamically if possible. I don't want to have to author like a custom proxy object for every ship. Once we have the sim version, the proxy version of it should be driven by that sim. So what we could do is we could then get our proxy to spawn all of the actors it needs. Maybe just with an ID. And the ID can just be the array number on here. That might work actually, because we've got our array index. So if we just create an object, so we spawn it and add it to an array, then we're just comparing indexes. But at what point do we spawn them all? That's the question. Because we need to add them all. We need to spawn the child actor, or the component, then add it to an array. Based on this. So we need to do an initial setup event. Where we won't have spawned our proxy yet. Yeah, so if we do that when we spawn the proxy, we need to set that anyway. So we spawn our proxy mesh. Sorry, yeah, we set the mesh for objects. So then we need to set thrusters. So we'll do the initial setup of the thrusters. Because we've already created this array by this point. And then we need a setup event on here. So if we do a custom event, spawn thrusters. Right, so for each one of these, we are going to add a static mesh component. May as well just do that, that works. So that should at least set up all the thrusters. And then for each one of those, we need to add them all to an array. Which we will call thruster effects. That needs to be an array. So that one can get deleted. can get renamed. So we'll add our static mesh to there, and just to make sure that we don't have any lingering stuff at any point. We'll just make sure we clear the array first. Okay, so that should give us an array of thrusters. And then when we check our thrusters, all we care about at the moment is whether or not they're firing. So I suppose I need to loop through that one. Oops. And for each one of these, we're going to get the same index from our thrusters array. And then we're just going to set visibility. So if they're firing, then we make them visible. If they're not firing, then we do not. Right, so that means we don't need to do any searching or looping through another array. We're just going through our list of static meshes and hiding them or not, depending on whether or not firing is set in the thrusters array. And then we'll be updating that as part of our tick. So that just needs to be spawn thrusters. So we'll set the array, spawn thrusters, and that should be that. And then, oh yeah, we're not doing it on loop, are we? We're doing update proxy. So we're updating the proxy every millisecond, which is probably not enough, to be honest. Alright, so if we do it at 60 FPS, we're only checking it at 30 FPS, so that should do that. Because we want it to be responsive enough that if you're just tapping the keys, it's not missing the fact that the RCS should have fired for that millisecond that you were just tapping the key. Let's see if that works. Actually, when we do the setup event, let's make sure we actually set the static mesh, obviously, which is just a cube. Make sure we've just got the engine. That's the wrong cube. Basic shapes cube, and the material for said cube is that red LED. So of course all the potatoes have immediately gone red. Oh, wrong one. Oh wow, that's some journey delta. can't see them. Okay, so it's not hiding them. Okay, so we're setting thrusters there. Updating that as we go. We're setting that on spawn, so let's just see whether or not this is actually doing anything. So this should be a lot of spam. Or none at all, which means something didn't happen. Let's make sure that I haven't typoed that. Oh, I did. Look. Ha! There we go. Typo was the problem. Right, so none of the thrusters are visible now, so that's a good start. That is correct. Okay, moment of truth. Huzzah, we have visible thrusters. Some weird roll behavior though, it's kind of... Oh no, it's alright now. It's almost like it was stuck on something. Have a good one, Daniel Jackson. Well, that definitely seems to be working. Yeah, I think G-load is probably something that we won't have to worry about because we're not going to be doing really high G maneuvers in these big ships. In the smaller things like shuttles, then maybe we'll have a look. As with all things, we'll look at real world planes and figure out what G loads are acceptable for human pilots. But yeah, when it comes to inertial dampeners, the idea is that the gravity field that we're generating can be angled. So we're angling the gravity field like in opposition to any forces that are occurring. So as you're accelerating, rather than you falling backwards because you're accelerating, the gravity field will push forwards, so to kind of like counteract the g-forces. To some extent. Obviously that won't be perfect, but that's the general idea of it. Thank you, Danger Mouse. Happy New Year. Right, let's make those thrusters more obvious. Well, we do plan on getting that 24-hour stream visible and fixed. It definitely is there still on the back end. So when we go to our channel dashboard, the stream is definitely there on the dashboard. We just need to figure out how to get it to start processing, because it won't let us download it or anything. It's just stuck, waiting to be processed. We need to contact YouTube basically and ask them what to do about it. Let's make a new material. Let's call it RCS effects. So we just want a simple vector parameter for the color, and we'll make it like blue or like purpley blue. Tweak that over time, and then we need scalar value. How to material. Right, multiply that by a scalar. So we want surface unlit. Something like that. See if that's any more obvious. So they need to be bigger and brighter. Yeah, we have debated having a Dan cam. I just noticed actually all the thrusters they don't have the right location, right rotation. So that all of them are oriented like to the ship. No matter. But yeah, but obviously the point being, we have visible RCS thrusters that actually do stuff when you do stuff, which was the goal. And we have full sublight control of the vessel, albeit a little sketchy because the center of mass is a little bit off. But yeah, it's nice to have some sublight, like proper physics-driven sublight flight. Just need to turn up the thruster power when doing lateral movement, because it really doesn't slow down very much at all. Ramming speed. So as of right now, there's actually no upper limit to how fast it can go. So just thrusting away should just keep thrusting and speeding up and speeding up. I guess the next thing we need to do is actually work out the speed of the ship in a straight line, which is not always straightforward. Yeah, we'll have a closer idea how close we are to say our early access goals when we do the Trello over the next week or so. So Claire's already translated much of the in-game systems onto the Trello, and what I need to do is I need to go through and work out what are the absolute core systems that need to be finished and polished for that early access release. And in addition to those core systems, we obviously need those gameplay elements as well that they relate to. So the upcoming roadmap, I suppose, for 2026 as a whole is going to be encapsulated in one giant Trello. So we'll be able to see at a glance just how far through we are with all the things that we need to do. So hopefully that Trello will encompass like literally everything that I need to finish this year. So then we'll know, then we'll have a percentage of just how far into it I am. That's a good point, Cloud, yeah. Well, to be honest, we're not far off Star Fury now. I mean, we've got all the components we need to be able to make a Star Fury. In fact, yeah, actually, we absolutely have. We could easily make a Star Fury now. But yeah, I mean, calculating how fast something is moving in a given vector is actually really difficult, because all you know from an engine perspective is how fast you're moving in a particular X, Y, or Z, not a combined vector in space. So in order to work out the actual speed of the ship, you need to kind of do a combination of those vectors and work out which direction you're going in. I did it before years ago, and I remember it being an absolute headache. But yeah, we need to do it again for sure. But yeah, anyway, so I think that is all of our objectives achieved tonight. So we've got a ship. Well, the Caravella is now sublight flyable using the helm controls and helm seat. It's fully physics driven now. There's no fakery going on. Actual thrusters actually pushing the ship about. And we can see those thrusters performing their job on the proxy object. So yeah, I think we are definitely on a roll. So I shall leave it there, and I shall wish you all a good week ahead. What are we on? Sunday. So yes, I shall see you on Wednesday for more Magellan class shenanigans. Alright, have a good one everyone, and I shall see you Wednesday. Bye for now!